Hey, mathletes. In this lesson, what we're going to look at is we're going to look at absolute value equations. So the past couple of lessons, we were looking at expressions and their graphs. What we'll do now is we'll, again, answer math's greatest question, right? What is x? So let's go and look at a couple of these things. Solve the following. Absolute value of x plus 5 is equal to 4x plus 1. Okay, first thing you're always going to do, let's graph this thing, right? So grab your graphing calculator and let's graph this thing. So I've already got it inputted in y1 and y2. Again, it doesn't matter where you put them in the order. Hit graph, and your solution to the equation is where those two lines cross. So the point of intersection, the x value, because we're only looking at x's, right? Oops, I hit the wrong thing there. Intersect. First curve, sure. Second curve, sure. Guess, who cares? There it is. Answer is x is 1.3 repeating. What's that? 4 over 3, I believe. Okay, so we know the answer. Let's go and show it algebraically. So again, always do this first, right? Always go and graph it and get the answer first. You might as well. So I know the answer is 4 over 3. So I'm just going to write it up here and say, oh yeah, that's my answer. Now, how do I show this? Well, remember when we were looking at the absolute value of x, that we have, again, two portions. We've got the positive portion and the negative portion. And that's what we need to take a look at here, is when we've got this absolute value, what we're going to do is we're going to say, look, there's two pieces to this. Case one is this was the positive portion. So I say what was in the absolute values was the positive portion. That's kind of case one. Case two, I'll just come over here and call this case two. Well, if I was looking at the negative portion, like that. So now I've got two little mini equations. Well, these are just linears, so let's just solve. So case one, I'm just going to subtract x and subtract 1 and divide by 3. And hey, look at 4/3. That's what I saw up there. Okay, bueno, that's good. Okay, what about on this one? Okay, so what I'm going to do is I'm going to remove my parentheses by distributing that negative. And I'll move all my x's to the right-hand side. I'm going to subtract 1. So I add x over, and I get 5x. Ooh, almost made a mistake there. I get 5x. So I get x is equal to negative 6 over 5. So I box that. But then I say, well, wait a minute. I didn't see that as a solution when I graphed it. Okay, here's why. What's going on with this? Well, what we're always needing to do, or what we should always do, right? We should always check our work. So let's go and verify these things. So I'm going to verify x is equal to 4/3 first. So what I'm going to do is I'm going to sub it back into my original expression, absolute value of x plus 5. So again, do these separately, left-hand side. So absolute value of x plus 5. So x is now, we're thinking 4/3. Okay, well, what's that? We'll get a common denominator. That's 15 over 3. So this is 19 over 3, absolute value, which is 19 over 3. What was the right-hand side? Well, the right-hand side, we said, was 4x plus 1. So 4, x we think is 4/3 plus 1, which is 16 over 3, which guess what? It's 19 over 3. Boom, verified. Okay, what happens when we try to verify this other guy right here? Let's verify that x is equal to negative 6 over 5. Okay, so let's do it again. Left-hand side, what does it give us? So we sub that in for the x value in the original equation. We simplify that down, so that would be 25 over 5. So that sounds like the absolute value of 19 over 5, which is 19 over 5. What do we get in the right-hand side? Well, it was 4x plus 1. So 4 times negative 6 over 5 plus 1 is negative 24 over 5 plus 1. That's then going to be 5 over 5. So that's going to be negative 19 over 5. Well, does positive 19 over 5 equal negative 19 over 5? Sir, no, sir. No chance. So what just happened? Well, what we just found here is that for this second root that we thought we had found over here, -6/5 isn't a solution. This is again called an extraneous root. And what I need you to do is cross it off and state that it's extraneous. Now, the good news was because we had graphed this, we knew that wasn't the solution. But when we're asked to do these things algebraically, I want you to show me that. I want you to show me that you know it's extraneous. Okay, there it is, friends. So what we do again, when we have the absolute value, we're going to break it up into its two portions. The positive portion, the negative portion, we solve and we verify if our solution is actually a solution. It's a good thing to do, right? All right, here we go. We got ourselves a quadratic on this one. So again, what we're going to do, I'm going to break it up into kind of its two component parts, the piecewise function. Here's the positive part. Here's the negative part right here. So we make it negative, okay, like that. And now we just solve. So on some little mini equation number one, okay, I'm going to bring the 2 to the other side and I'm going to factor if I can. Okay, well, what's two numbers that multiply to -2 and add to +3, or multiply to -2 and add to -3? Oh, uh-oh, we might have something going on here. Okay, what are we going to do? Well, geez, I can't think of two numbers that do that. So what we would have to do then is we'll have to use the quadratic formula on this thing, won't we? Okay, well, let's go ahead and let's try that. Okay, so what happens? So let's use the quadratic formula. So -b plus or minus, okay, -3 squared minus 4ac all over 2 times a, and a is just 1. All right, let's just keep simplifying. So x is equal to 3 plus or minus square root of, what's our discriminant here? Well, it's going to be 9 plus 8, so square root of 17 over 2. Okay, and what do we get here? Well, there's nothing that simplifies, so that would be one of our roots. It's not very pretty, but there it is. Okay, what about on the other side? Little mini equation number 2. So again, I'm going to get rid of those parentheses by distributing in that negative. Okay, this time I'm going to move all my x's to the other side. Yeah, I just like my x squared to be positive. Okay, this guy at least thankfully is a little easier to factor, isn't it? Right? So this will be x minus 2 and x minus 1. And we solve using the zero product property. We get 2 and we get 1. So at this point, look at this. We've got actually 4 solutions at this point, right? We got 3 plus or minus root 17 over 2, and we've got x is equal to 2 over 1. So if I didn't have a graphing calculator at this point, like I'm going to have to verify all 4 of these, all 4. Okay, well, let's just, because we do have a graphing calculator, let's just go and see. So let's go and graph what we had. So the absolute value of x squared minus 3x. So let's clear this out. Math num that. The absolute value of x squared minus 3x. And on the other side, we had just positive 2. Let's go graph this. Graph. Okay, look at that. How many solutions should we have? Well, I see those two lines crossing, intersecting 4 times. So I'm pretty certain then that when I go and look at my work here, we came up with 4 solutions. There they are. Now, on a test, if I was asked to verify, then I would verify all 4. I just visually saw that there was 4, so I'm pretty happy, but I'm pretty sure we did it right. Okay, friends. So again, the key thing that's going to happen here when you're doing these questions, I'm going to go back up to the first one. You're going to break it into the positive and negative portions. You're going to solve, and the thing that I really need you looking out for is that right there, that extraneous root. Okay, keep an eye out for it. It will occur.